Hello, myself Prashant Das, a 6th semester student of Mechanical Engineering Department at Tezpur University. Today I am going to write actually a MATLAB code using finite volume method to solve 1D steady state convection diffusion equation. For that I am using upwind scheme as well as central differentiating schemes, and later on I will compare the results with high Peclet number. So let's start. Here in the MATLAB code, the first three lines we always do is to clear all the variables and all the figures as clear all, and command window, so that we can start with a nice clean command window. And the second step I am defining the problem, and for that the total number of endpoints, that is here 101 is a total number of mesh point that I am assuming as 101, and my domain length is 1. Later I am calculating as h is the grid spacing, that is calculated as domain length divided by endpoints minus 1. And here x is the x coordinate of each point, that is starting point from 0 and goes to domain length as a grid spacing of h, that is already calculated in the above. Here as a initial condition I am taking phi 1 as 10 and phi endpoints is equals to 20. Here rho is the density of the system, and u is the fluid velocity. Gamma here is the diffusion coefficient, and here p is a Peclet number, that is calculated as rho multiplied by fluid velocity multiplied by domain length total divided by gamma, that is diffusion coefficient. Here exact solution I am calculating as I am giving the variable name as phi exact, that is calculated as phi 1 plus phi endpoints minus phi 1 multiplied by exponent p into x divided by domain length minus 1 total divided by exponent of p minus 1. Here p is the Peclet number, and figure 1 is the name of the figure, nothing else. And here I am plotting the curve as x versus phi exact. Phi exact is in the y variable, is in the y, and x is x in the x axis, and phi exact is in the y axis. Here rp is a curve. Here rp is to show the curve as red. Here r is red and p is for pentagonal structures that I am going to plot as a curve. Now I am calculating as a differentiating scheme. Here error is initialized as 1 for to calculate the while loop, and my iteration is starting from 0, and the points that I am calculating is the interior points, not the boundary points, so that's why it's starting from 2 to endpoint minus 1. Here AE, AW and AP are already calculated, that is here gamma by h is a diffusive term, and minus rho multiplied by fluid velocity divided by 2. Similarly I am calculating the AW and AP. Here phi nu is the discretized form of the above three equation, that is AE multiplied by phi I plus 1 plus AW multiplied by phi I minus 1 divided by total AP. And here is the loop ends. This loop is calculated for one iteration. For that I am using iteration is equal to iteration plus 1. Again the error is 0 to calculate the error value, so that the result gives the results comes accurate. For that I am using error is equals to error plus, here error is a cumulative error plus absolute error, that is phi I minus phi nu. Phi nu is already calculated as a discretized form, and also the loops ends here. Now I will show the curve of a Peclet number, that is equals to 0.1, because I am giving the velocity as 0.1. All the remaining terms, that is rho and gamma, are 1. As I can see here, at x equal to 0 the value of phi is 10, and at x equals to 1 the value of phi is 20. Here it is giving me a straight line. If I increase the value of Peclet number, that is by increasing the fluid velocity, then I am going to have a different result. And let's see how it varies with fluid velocity. Let's say I am going to give a fluid velocity as 10 and see how it varies with Peclet number. As Peclet number is going to be high, that is, earlier I have taken as 0.1, now it is 10. As we can see, by increasing the fluid velocity, the curve changes and it varies with high Peclet number. If I give the negative velocity, means not the negative velocity, I am going to calculate the Peclet number that is less than 1. So I am going to give minus 5 as fluid velocity. Let's see what varies with Peclet number. As we can see, the Peclet number is varies with, earlier it was a straight line and then it's the curve going upwards as Peclet number is less than 1. And as I earlier showed that if my Peclet number is greater than 1, the curve becomes downward. Now I will compare the results of varying Peclet number, that is Peclet number starting from 0.1, then 1, then 10, and then minus 5 to see how it varies with high and low Peclet number, that is with Peclet number less than 1, Peclet number greater than 1, as Peclet number close to 0. As you can see, this is the curve for Peclet number 0.1, that is closely, or we can say approximately is equals to 0. And this is the curve for Peclet number, that Peclet number is equals to 1. And this curve is for Peclet number is equal to 1, which is greater than 1. And this curve is for Peclet number is equal to minus 5. As we can see, by increasing the Peclet number, how the curve varies from straight line to the curve downwards, and for Peclet number less than 1, the curve goes upwards. Thank you.